Okay? Literal equations and formulas. We're still going to be using our solving for a variable techniques. And you'll see what we mean by literal equations, and then you know what a formula is. We're going to move around some things in formulas using our solving equation stuff. And this is going to be a little bit odd, so hang in there with it. Okay? So first, some vocabulary. What is a literal equation? Well, a literal equation is an equation that involves two or more variables. Okay? So that's it. And almost all formulas are literal equations. Okay? They'll have at least 2, 3, 4, sometimes 5 variables in a formula. It says formulas are an equation that states a relationship among quantities, right? What's the relationship between Celsius and Fahrenheit? What's the relationship between the length and the width of a rectangle and the perimeter, right? I mean, all these are formulas that state a relationship among different quantities. Okay? Formulas are, like I said before, a special type of literal equation. They're going to have 2 or more variables. What can be confusing is that sometimes formulas use the same variables, but they have different meanings. Right? So in the formula C equals 2 pi r, right? The C means circumference. But in the formula for converting Celsius to Fahrenheit, we're still going to use the uppercase C for Celsius. So obviously the definition of those variables is going to be situational, depending on the situation that we're in. Right? Okay. And there are a bunch of pretty standard formulas that you're going to see quite a bit throughout your math and science career. Okay. Need some more? Go back. Okay. So some pretty common formulas you're going to see in math and even some in science. I'll let you guys copy those in real quick. You've got perimeter, circumference, some couple of area formulas, distance, which we're going to get into a lot. Okay. O plus 2w, right? Circumference 2 pi r of a circle. Area of a circle is pi r squared. Area of a rectangle, triangle. You guys have seen these before. Not the first time, I'm sure. The distance traveled. Just take the speed times the time it's traveled, and that'll give you distance traveled. And then you see the conversion there. From Celsius to Fahrenheit, and you can always manipulate the formula to go from Fahrenheit to Celsius. Okay? And that's what we want to do. What we're talking about is taking some of these formulas or any literal equation and isolating a variable that you might want to try to find the value of. Right? That's the idea behind solving literal equations. Okay? It involves the same steps as solving a one-variable equation. Right? So we're going to isolate one of the variables. Remember what isolate means. Get the variable by itself with the coefficient of 1. And we do this the same way as we've been doing everything else. We're going to undo addition and subtraction first. Right? In other words, clear out any of the terms on the same side of the equation that your variable that you want to isolate is on. And then you'll clear out any kind of coefficient or any multiplication and division happening to that variable that you want to isolate. And notice that it does say isolate one of the variables, not isolate the variable. Because again, there's going to be more than one. And the variable that you want to isolate might change, depending on the situation as well. Okay? So, for example, right, we want to rewrite the literal equation for the identified variable. 4x plus 2y equals 8, solve for y. Also known as, what? What's that called if you solve this thing for y? You've seen it before. Talked about it before. If we solve that equation for y, what's that called? Anybody remember? Got it? So, what do? I want to solve for p, right? If the variable I want to isolate, I don't want to move that guy. I want to keep that guy right where he is. That means I want to move the other term. Okay? So I want to zero out the m term. Now again, negative 2 and negative 2m are not like terms. So I cannot combine them. Okay? And then I have to get rid of that 6, so I divide through by 6. Now, a couple of you guys did this, and that's why we're doing these together, right? Negative 2 over 6 is a fraction. If you reduce it, it's going to stay a fraction, right? It won't automatically or magically become a whole number. So just be careful. This is going to be 1 over 3 minus 1 over 3m. What's that?
Does it matter where we put the m?
Well, I mean, in this particular equation, it may not matter a whole bunch because these are the same.
Like, does it matter like what spot?
Like if you move this guy over here?
Yeah.
No, that'd be fine.
Okay.
Yeah, that'd be fine. As a matter of fact, mathematically speaking, that's probably a little bit more correct. Okay, just a little bit of math, type A stuff. Anyway, but yeah, good question. All right, any other questions about that guy? Okay, let's try it again. Negative 3r minus 2w equals 6. Solve that guy for w. Okay, got it? Got it? Negative 3r minus 2w equals 6. Solve for w. First thing you want to do?
Add 3.
Yep, add the 3r. Right? The w is what we want to isolate. Get the other terms out of there. Right? Don't forget to bring down your negative. Your minus sign is a negative. And also don't forget that you cannot combine the 3r and the 6. They just stay the way they are. Then divide through by negative 2. Right? So w is negative 3 halves r minus 3. Okay? It's barely a 2. Issues there? Any question? You all right? Okay, got another one for you. Okay? P equals 2L plus 2W. We're going to solve this guy for W, right? That means I want that guy, I want to leave him alone. I don't want to move him. I don't want to do anything with him. So let's move the other guy first. Subtract 2L. Okay, zero that 2L out.
What?
It's a 2L.
I'm so confused.
Why? That was an L, right?
Yeah, but where do you get the L from?
Yeah. And then now, again, we don't want to do anything with the W. We want to clear everything away from the W. So we got to divide through by 2. You go P over 2, right? Minus 2 divided by 2 is 1. So you can just leave it as L. Okay? Does that make sense?
I mean, if I knew there was a 2, I mean an L.
Okay. Besides telling the difference between a 1 and an L. Does that make sense? Yeah, Christian.
There's a P over 2 minus L. I got that, but I flip-flopped it.
So as long as it says, as long as yours looks like minus L plus P over 2,
I have minus 1L plus P over 2.
then you're fine. You're absolutely fine. That'll work. Okay? As long as your signs go with the flip-flopping, you're fine. Okay, anybody else? Issues here? Okay. Okay. All right. Now, there are some formulas that they don't have this extra term on them, but they've got a couple of, a couple of coefficients is kind of a rough way of saying it, but we have some things, and we have more than just one numerical coefficient to try and clear away from our variable. So like for number 5, we got C equals 2 pi r. That's your circumference formula for a circle. Well, if you want to know the radius, or if you wanted to get the radius by itself, okay, then we need to get r isolated. We need to get everything off of the r. Right now, this means 2 times pi times r. All that's being multiplied together. Well, to undo that, we have to use division. So we can go ahead and divide both the 2 and the pi at the same time. Because these are both going to divide out to 1. We're going to be left with r, and so what we get is c over 2 pi.
So you always drop the last.
Not necessarily the last one. You're just going to divide by everything except what you're trying to isolate.
Okay.
Does that make sense?
Yeah.
Okay. Good. Then you guys try. Number 6. Okay. So what we got? So we want to get b by itself, right? Okay. So what are we going to do? Okay. Well, this is kind of weird. I've got a fraction in here. We talked about last time being able to clear fractions, right?
Yeah.
By multiplying by the common denominator, right? What is the common denominator in this on all this stuff? 2. So multiply both sides by 2. Okay, yeah, so it'd be 2a. And the 2's will divide out, leaving us with just BH. Okay? And then divide by H. And so we get 2a over H. Okay? Always a little tough to figure out what to do with the fraction, but now that you've seen it, you can do it all the time, right? Any questions there? Okay. Got another one real quick. Try that guy. Got it? Solve for r. R is equal to d over t. Just divide both sides by t. Okay? And that's it. R is by itself. D over t. Okay? All right. Now, the point behind this is if you want to find the value of one of these variables in a literal equation, then if you can isolate it, then any value you plug in for any of the other variables, all you're left with is just some arithmetic and order of operations to make sure that you can find those values, right? So for example, we've got this literal equation, m plus 3n equals 7. And we want to first solve the equation for m, and then find the value of m for each of these values of n, right? So, after all of this, we look at m plus 3n equals 7, and we know that to get m by itself, to isolate the m, we simply have to subtract your 3n, right? So we're left with m equals, again, we cannot combine those guys. They are not like terms. Negative 3n plus 7. Okay. Now, it becomes pretty easy to find the value of m. Okay. So for values negative 2, 0, 1, we want to find the values of m. And guys, you need to show your work. On your test, not a lot of work shown, or some of you guys didn't show your work, and that cost you some valuable points. Okay? But all we got to do now is start plugging in values for n. So first, if n is negative 2, negative 3 times negative 2 is 6. 6 plus 7 is 13. Plug in 0 for n. Negative 3 times 0 is 0. 0 plus 7 is 7. And then plug in 1 for n. 3 times 1, or negative 3 times 1 is negative 3. Negative 3 plus 7 is 4. Okay? Had we not solved for m and just started plugging numbers in for n, we would have had an equation that we were going to have to solve anyway. So whether you manipulate or move everything before you start plugging numbers in or after, you're going to have to do some solving. Okay? And so we do it here at the beginning, just try to make life a little bit easier. Okay? Make sense? Then you try. M by itself. All right? I caught some of you guys already. So at this point, we're all getting pretty good at the fact that we've got to subtract this 4n to both sides. Okay, no problem. But the m's not by itself yet. Okay? Divide through by negative 1, so that m is all by itself. Okay? Then get into your table. Right? So now m is going to be 4 times negative 5 minus 4. So it's going to be negative 24. M is going to be 4 times 1 minus 4, which is 0. And I'm running out of space. M is going to be 4 times 3 minus 4, which is 8. Okay? Just be careful. Just make sure the m is all by itself. It's got to be all by itself. All right? Questions there? Okay. Got one more, I think. One more? Oh, yeah. And we got a couple of applications here that we can use. Get m by itself. Right? So first things first, subtract the 4n. Okay? That's got to go away first. Then we can go through and divide by negative 6. So you're left with m equals negative 4 over negative 6 reduced is 2/3. Negative 2 over negative 6 reduces to positive 1/3. Now some of you guys may have it flip-flopped. You may have 1/3 plus 2/3 in, and that's completely fine. That's completely fine. Okay? And then once we're here, we come up with our table.
Wait.
Yep. You okay? I thought you said wait. Okay.
I was talking to Henry.
Okay. So m is 2/3 times, we're going to plug -3 in for that n, plus 1/3. Okay. Make this a fraction. -3 times 2 is -6. -6 divided by 3 is 2. Actually, negative, sorry. It's negative. Plus 1/3. Okay. -2 plus 1/3 gets you -1 and 2/3. Okay, if you need some assistance with that, then come talk to me. Star or after school or something like that. Okay? 2/3 times 0 plus 1/3. Right? That's just 0, so you get 1/3. And then plug in, I can't do it over there. Two-thirds times 3 plus 1/3. Very, very bottom down there, nice and cut off. 3 times 2 is 6, divided by 3 is 2. So you're left with 2 plus 1/3, or 2 1/3. Not 21/3. 2 1/3. Some fraction math there. Okay? Questions there? Probably won't have very much in the way of crazy fractions on quizzes and tests with this stuff, right? But, sorry. Okay? Now, some stuff we can do. A little bit of application stuff here, right? So the formula, A equals LW, length times width, gives the area of a rectangle given the rectangle's length and width. Solve the equation for W, and what's the width of the rectangle? What's it have to be if the length is 14 centimeters and the area is 161 square centimeters? Okay? Well, looking at the formula, solving for W, hopefully, is not that tough anymore, right? We want to isolate the W, so that means I want to divide by the L. And so the formula turns into area divided by length. That lets you know how to find the width. If I know the area and I know the length, then I just divide those guys. And that's exactly what I know. I know the area and I know the length. The area is 161. And the length is 14. So when you divide that out, you get 11.5. Thank you. Centimeters. Okay, so by isolating the variable first, it reduces the amount of work you have to do after you plug numbers in. Okay, but that's the point. Questions there? Okay, then you try. Let's take a look. So P equals 2L plus 2W. We want to solve this for W, right? Which means that I want to zero out the L term. Okay? Which means that we want to subtract the 2L. Okay? Not divide, but subtract. So P minus 2L, we can't combine like terms. It just becomes P minus 2L. Okay? Not dividing. Okay? So be careful with that. And then we're not done here. The W is still not all by itself. We've got to get rid of that 2. We've got to divide through by 2. Since that's 2 times W, we're going to divide through by the 2. And so we're left with W equals, so P over 2 These two are going to divide out. 2 divided by 2 is 1. And so we're left with P over 2 minus L. Okay? And now we have some information. Everybody okay there? All right? Yeah, question.
Why wouldn't we add in the 182?
I wouldn't do it until after you've gotten the formula solved for W.
Oh, I went ahead and added it and solved it.
Okay. Well, I mean, that's definitely one way you can do that. But like I said before, if you plug in the numbers now, you're going to end up solving an equation. That's what we're doing before we plug the numbers in here. So it's whether you do it before or do it after. You're still going to have to do the same thing, right? Right? The point here is when you plug the numbers in, all you're doing is doing some arithmetic and hopefully a little bit easier. Okay? So yeah, we're going to plug in, the perimeter is 182 inches. That's going to be your P. The length is 52 inches. And that's going to help you find W. Half of 182 is 91. Subtract those out. And the width is 38. What? Not 38. 30. Sorry, 39. Sorry. Yeah, you should end up getting the same thing. Okay? So the width is 39. Questions? Yeah.
On the test, do we have to do it that way, or can we?
The only thing I'll tell you is that in the directions it says solve the equation for W. Okay? In the absence of being forced to solve for a variable, then you can do it however you want. But if you just make sure you pay attention. If it asks you to solve for a variable, I'm going to expect you to do that. Okay? Good. Any other questions? Okay.